what is the composition of the atmosphere? All right, so we got this atmosphere, and we mentioned that the sun's energy shines through this atmosphere before it hits the surface of the Earth. It's got to go through the atmosphere, and it goes through the layers, the troposphere, stratosphere, mesosphere, thermosphere. It's got to go through those layers before it hits the atmosphere. Well, we know that there are those layers, and we know that the temperature is different. We know that the pressure is different. We know that the water vapor content is different. But what is that atmosphere made out of? What is the air in our atmosphere? Well, the focus of this is going to be just on the troposphere. So when we say what is the composition of the atmosphere, we're going to really focus on just this bottom layer, since this bottom layer is where all of our weather takes place. The majority of our weather takes place here in the troposphere. That's what our focus is going to be. So when it says what's the composition of the atmosphere, we're going to focus on just the troposphere. So imagine we took a little box of the troposphere. We're just going to take a little piece of air out of the troposphere. So imagine we just took that box and we're plopped that right out of the troposphere. And let's take a look. What is that made out of? So here's a little box of air. What is that air made out of?
Oxygen. Carbon dioxide and H2O. And water vapor. Carbon dioxide. That's it.
Okay, that's a lot of stuff. So we've got oxygen. You know, that's that stuff that we breathe in. And when we breathe out oxygen, what we're breathing in is a molecule of oxygen that's made up of two oxygen atoms that are combined together. So the oxygen is O2 that we breathe in. It's not just one atom of oxygen. It's actually a molecule with two atoms that are bonded together. There's carbon dioxide, of course, as well. And that carbon dioxide is CO2. Right, it's two oxygens and a carbon together, so it's carbon dioxide as well in the air. There's also the nitrogen in the air as well. And just like the oxygen, that nitrogen is made up of two atoms bonded together. So we got oxygen, carbon dioxide, nitrogen. The water vapor. And there are others such as argon. There's also a little bit of hydrogen in the atmosphere as well. There's a few others. So if that's what we're breathing in, when you guys breathe in and breathe out, you're breathing in this air. And so what is the composition? How much of those things are there? The majority, all right, 78% of what you're breathing in is nitrogen. So if we were to take a look at this box here, we could set this up. 78%, most of what you're breathing in is nitrogen. So when you guys take a big deep breath, you're breathing in mostly nitrogen. That's the majority of what you're taking a breath of. 21%, so we don't have a whole lot left, right? 21% is oxygen. So we have 21% is oxygen. And just that little bit on the side is all the other gases, the carbon dioxide, the argon, water vapor. That's everything else fits just into here. So when you breathe in, most of what you're breathing in is nitrogen. 21% is oxygen, and 1% of all those other gases. That's what our troposphere, where we live, when you breathe in, that's what you're breathing in. This is not something you need to memorize. You can just go to the front page of your Earth Science reference tables, and there's a chart, all right, on the front page of the reference tables that talks about the chemical composition. What are these things made up? The chemical composition of the troposphere. And it doesn't just give the troposphere, it also gives the crust and the hydrosphere as well. But if you look under troposphere, you'll notice that 78% is nitrogen and 21% is oxygen, which gives us that's 99%. 99% of what you're breathing in is either nitrogen or oxygen, and only 1% of that other stuff. There's only 1% of the other stuff. Not only on this chart do they give you the troposphere, but you'll notice that there's also information for the crust of the Earth, and another name for the crust is the lithosphere. And the lithosphere, lith means rock or solid. So the crust, the lithosphere, is the stuff that we're standing on, the solid part of the Earth, all the rocks. And you notice that oxygen makes up a very large percentage of our rocks. And they also give us the hydrosphere as well. Hydro, fire hydrant, right? Hydro means water. And so this is all the oceans and lakes and puddles and spit that's around on the Earth. So the hydrosphere is 66% hydrogen and 33% oxygen, which makes sense. We're talking about H2O, right? H2O is water, so there's going to be twice as much hydrogen as there is oxygen, and sure enough, 66 and 33%. So not only is there information on this chart about the troposphere, about the atmosphere, but they also give you information about the crust of the Earth, known as the lithosphere, as well as the water on the Earth, the hydrosphere as well. So where did all these gases come from? You know, in our atmosphere, the atmosphere has all this gas. Where did the gas come from? Well, it turns out that in the early atmosphere, there wasn't a lot of hydrogen. There was a lot of hydrogen, but not a lot of oxygen. There wasn't too much oxygen in the air. There wasn't even a great deal of nitrogen either. But a lot of this gas came out of the Earth from what we call outgassing. So imagine we've got a nice volcano here, and there's some magma underneath. And when magma and lava comes out of the volcano, that forms new rock. But there's also a lot of gases that come out as well. So these gases come shooting out, and some of the gases include things like nitrogen and carbon dioxide. So these gases were ejected into the Earth's atmosphere to form the early atmosphere of the Earth. There was a lot of carbon dioxide, there was a lot of nitrogen in the early atmosphere. This is known as outgassing. The early atmosphere was made up of a lot of carbon dioxide, nitrogen, and that was caused by outgassing from a great deal of volcanic activity. The oxygen in the Earth's atmosphere came from life. When we had photosynthetic organisms, a lot of algae and things in the oceans, they started using the carbon dioxide that was in the atmosphere and increasing the amount of oxygen that was in the atmosphere. So when we look at carbon dioxide and nitrogen from outgassing, but the oxygen that we presently have in our atmosphere came from life, came from photosynthetic oxygen-producing organisms. You guys remember photosynthesis is using carbon dioxide and the energy from sunlight to create sugars and byproduct of oxygen. All right, so remember we've got our atmosphere and we know what it's made of now. We know that there's a number of different layers. Let's go back to the type of energy. So I just drew one squiggle here to represent the sun's energy, but remember if that was visible light, we also have other things as well. We've got some longer waved infrared radiation coming down. We've got some shorter waved ultraviolet radiation that's coming down as well. We also have some even longer radio waves. We even have super short gamma ray radiation that's coming down. There's different types, and these types of energy are going to interact with our atmosphere in a different way. So remember, we've got our atmosphere here. We said, for us, we're going to say that the top of the atmosphere is about 100 miles up. The energy from the sun, because it interacts with the Earth's atmosphere, doesn't always reach the ground. Remember, so here's the surface of the Earth down here. One of the types of energy that comes down from us is this ultraviolet energy, right? Ultraviolet energy is coming down from the sun. That ultraviolet energy doesn't all reach the Earth's surface. As the ultraviolet rays enter the Earth's atmosphere, not all of them make it down to the surface of the Earth. There's something in the Earth's atmosphere that stops a lot of these ultraviolet rays, and that's the molecule ozone. So ozone absorbs a lot of that energy. Now, ozone is a molecule that's made up of 3 oxygen atoms. So ozone is O3. So that ultraviolet energy doesn't make it all the way down to the Earth. Some of it does. Some of that ultraviolet energy does reach the Earth's surface, and that's what gives us our sunburns. It could cause problems with cataracts. It also damages crops. It's the thing that when you leave something out in the windowsill, the color will fade. It's because of this ultraviolet energy. But the majority of ultraviolet energy is absorbed by the ozone in the atmosphere. Ozone is found from about 20 miles up to about 30 miles. That's where we find our ozone, that O3. Ozone does happen on the Earth's surface, but we usually call it a pollutant when it happens on the Earth's surface. It's one of the chief components of smog. But hey, 20 to 30 miles up in the air, we love it. It blocks out this harmful ultraviolet radiation. This is the UV radiation. When you put on sunscreen, this is what you're trying to block out. We've got some natural ozone that blocks that out up in the stratosphere. Ozone in the past was starting to deteriorate because we as humans produced a molecule called a CFCs, chlorofluorocarbons. It's a man-made chemical that was used on the Earth and was a wonderful product used in everything from cleaning. It was used in refrigerants. But when it got released into the atmosphere, the CFCs would destroy the ozone molecule. And that left a lot of problems, allowed more ultraviolet radiation to come in. The CFCs are now banned in pretty much every product. You won't find CFCs. It's been banned for decades. But it's still, the damage was done, and now our ozone layer is slowly getting better. So not only do we have composition of our atmosphere is not just nitrogen and oxygen, but these other gases are important. Some of them do some very important things for us, such as the ozone blocking ultraviolet radiation from hitting the Earth.